What is inverse kinematics in robot motion? Imagine telling a robot exactly where you want its hand to go, and it figures out how to move its joints to get there. That's what inverse kinematics is all about. It's a way for robots to translate a target position and orientation into specific joint angles or displacements. Think of it like giving directions to a friend. You say, "Move your hand to this spot," and they figure out how to bend and turn to get there. In robot kinematics, there are two main ways to understand movement. Forward kinematics takes known joint positions and calculates where the end of the robot arm will be. Inverse kinematics does the opposite. It starts with the desired end position and finds the joint settings needed to reach that point. This process is essential for tasks like picking up objects, welding, or assembling parts, where precision is key. Robots with multiple joints, like arms with 6 degrees of freedom, can reach the same point in space with different joint configurations. Sometimes, no exact solution exists because of physical limits or obstacles blocking the path. To solve inverse kinematics, engineers use two main methods. Analytical solutions use math formulas to find exact answers for simple robot structures. For more complex robots, they relying on numerical methods, which use computer algorithms to approximate solutions through iterative calculations. A tool called the Jacobian matrix helps in inverse kinematics by relating how fast joints move to how fast the end effector moves. It helps generate smooth paths from one position to another. In practical applications, inverse kinematics is used in industrial robots for tasks like sorting items, welding, or painting. It also plays a big role in humanoid robots, animation, and simulation, making movements look natural and precise. The number of joints a robot has, called degrees of freedom, affects how complex the inverse kinematics problem is. For example, a robot with 6 joints can position and orient its end effector in 3-dimensional space. But as the number of joints increases, solving the inverse kinematics becomes more challenging because of potential singularities, positions where the robot loses some movement ability, and joint limits that prevent certain angles. In essence, inverse kinematics is the process that helps robots figure out how to move their joints to reach a specific point in space. It's a fundamental part of controlling robot motion, allowing machines to perform detailed and accurate tasks in manufacturing, research, and beyond. Without it, robots wouldn't be able to perform complex movements with the precision needed for many applications.